multiplying binomials containing radicals, which is foiling. Basically what we're doing is foiling. Here's the good news. With the exception of the last part we're going to do, everything should make complete sense to you because you guys know how to foil and you know how to multiply radicals. Those two things are being combined together today, that we are going to foil things using radicals, which really you should be like, oh yeah, I know how to do this. So let me just make one correction here. This should be not two T's in outer. O-U-T-E-R. There we go. Let me make that correction. Okay, so we are going to simplify these. Notice that there are two binomials. And by binomials, when people say foiling, there's two things times two things. So we're going to do it the same way as always. First, outer, inner, last. So we've got FOIL. And I'm just going to do it in that order. So here is the F part. I'm only going to color code the first one. After that, I'm not going to do it. There's the first thing. First times first. What is 4 times 3? 12. And then I'm going to do outer times, that's not a highlighter. Outer times outer. So here is an outer one. Here is an outer one. What is 4 times the square root of 7? 4 square root of 7. Remember, outside numbers times outside numbers, inside numbers times inside numbers. Okay, now I'm going to go to inner and, I cannot get a highlighter to save my life. Inner and inner. So here's an inner term. Here's an inner term. What is square root of 7 times 3? 3 square root of 7. Notice those two inner terms there. Notice that there's something there. There's something that we're going to be doing there in a minute. And then finally, we've got our last term times our last term. What is the square root of 7 times the square root of 7? Don't simplify it. Just tell me what would be the next step. The square root of 49, and we'll simplify that in a minute. Okay, 12 is not going to simplify. It's just 12. Oh, so sorry. Thank you. I didn't see the 2.
Wait, so when you're multiplying the 4 and the 2 square root of 7, wouldn't it be 8 square root of 7 for the second one?
First times first, outer times outer, inner times inner, last times last. Let me just see which one did I do wrong. So first times first is 12, right?
Oh, the second one.
Did I do it? So outer times outer. Yes, I wrote 4. I'm sorry. I just, for some reason, I didn't see that 2 twice. Okay, so 8 there. Inner times inner is 3 square root of 7, and last times last is the square root of 49. Okay, so we've got 8 square root of 7 plus 3 square root of 7. What does that become? What is it?
12 to the 7 squared.
11 square root of 7. 8 square roots of 7 plus 3 more square root of 7 is 11 square root of 7. And then next we've got 2 times the square root of 49. What is the square root of 49?
7.
The square root of 49 is 7. So we get 12 plus 11 square root of 7 plus, what's 2 times 7? Anything left that can be combined there?
Yes, 14 and 12.
Okay, so we got 12 plus 14, which gives me 26 plus 11 square root of 7. There's our first one. Okay, so our next one. I'm going to do the exact same thing. Now, you might be like, but wait a minute, that's not two things. That's not a binomial times a binomial. But why is it a binomial times a binomial? How do I know that? Right, so I'm just going to rewrite this just so we can see it there. It is 2 square root of 3 minus the square root of 6 times 2 square root of 3 minus 6 square root of 6. Because remember that when we just have 2 of these, it's that times itself. So we're going to do first times first. What is first times first? I'm not going to underline, I'm not going to color code because you should know which ones I'm talking about at this point. 4 square root of 9. And again, just now that you've said it, I'm going to show it. It's those two together. Outside times outside, 2 times 2. Inside times inside is 3 times 3, which is 9. But this is going to simplify into 4 times what? I'm sorry, that's not a 4. 4 times what? 3. And what is 4 times 3? 12. There's our first one. I just kind of simplified it all the way down. Now, we are going to do outer times outer. What is the outer term times the outer term end up equaling? Yes, it is. Well, it is a negative because one's a positive and one's a negative. The one on the right is, this one is negative. So what does this end up becoming?
A 3.
Wait, what is the whole thing? Like when I multiply those two terms together, what do I get?
Negative 2 square root of 18.
Negative 2 square root of 18.
Oh, do you still multiply the inside if they're not the same?
The only time they have to be the same is when we're adding them. Adding or subtracting. In this case, we are multiplying, so we do outside times outside or inside times inside. So those are our outer terms. Let's do our inner terms. What does that end up equaling?
2 square root of 18.
Negative 2 square root of 18.
And that one is a positive 30, and then it's positive 30 square root of 36.
Okay, and a negative square root of 6 times a negative square root of 6 is a positive square root of 36. And what is a positive square root of 36? Because that one's really easy to do too. It's just 6. But let's deal with these two inner terms. First of all, these two things can be subtracted. Why? Like, why can I combine them?
Because they are the same.
They both have it. So what do I get when I combine them? Negative 4 square root of 18. If I have negative 2 of something and then I subtract 2 more, negative 2 minus 2 is negative 4. But I need to see if this breaks down.
Yeah, you could break down the 18. So that minus 2, and then you get 4 times, negative 4 times 3.
Okay, so negative 4 times, I did it again. I keep saying 4 and writing 3. Negative 4 times 3 times the square root of 2.
So negative 12 square root of 2.
Good, this becomes negative 12 square root of 2. So we get 12 minus 12 square root of 2 plus 6.
For the homework, it's all questions.
What? I don't know. Let's do notes first. I don't want to get to the homework yet.
I have a question.
Yeah, it is all. Yeah, it's all of them today. Yeah.
What did you do with the 18? Like the minus negative 2 square root of 18 minus 2?
Here, what did I do? How did I get to the negative 4 square root of 18?
What if you touched the 18?
Right, because when you're subtracting them, I've got negative 2 of something. Remember, like we did yesterday, when you're multiplying, that's going to change. But when we're adding 2 of something, it's like if you've got x squared plus x squared, what does that add up to be?
4.
No, that'd be if I multiplied them.
Oh, 2x.
That would be 2x squared. Notice it's still x squared. It's just I've got 2 of them. Same thing happened with the 18. I have negative 2 minus 2 more of those. Same thing. So when you're adding and subtracting, I don't expect that radical to change. And the only way that I could subtract them is if the radicals were the same. But I'm not done with this yet. Why not? The 12 and 6 can become 18 minus 12 square root of 2. C, I think, is the most important one that we're going to do today. The next one that we see is going to be the most important one to pay attention to, because it's going to be the one thing that helps us the most going forward. There's something special about C that is different than the others. What do you notice about C, even if you're not sure why it's special? Like,
They have something in common.
Oh, this is a plus and then there's a minus.
these are exactly the same with the exception of one of them has a plus and one of them has a minus. I'm not going to talk about what this is called yet, but trust me, by the end of this page, this is going to become the most important situation that we're going to use today. It's super important. But notice that I have got the same 2 things on both sides, but one of them is plus and one of them is minus. Like these 2 things are being added together, one of them is being subtracted. 2 of them are being subtracted, I mean. So let's go through and work this out, because here's what's important. When you see this pattern, I want you to pay attention to what the answer ends up being. So let's work this out. Talk to me. It's nothing different. No different strategy. Just it's interesting how the answer ends up.
It's going to be the 4 in the radical 5, and then the 4 first.
Okay?
And that's going to be 16 radical 25.
16 radical 25.
You just folded it.
Yeah, we're just foiling.
It's plus because this is the 4 bigger than the 3. Right?
No, but it's without multiplication, it's just a negative.
Multiplication, we're just doing outer times outer. So we're not,
Minus 12.
right? So we're doing here is a negative 12. And then what?
10 square root of 10.
Square root of 10. How about inner?
Then it's plus 12 square root of 10. And then
Last times last.
negative 9 square root of 4.
Okay, good. Let's do any simplifying we can do. What's the first thing we can simplify?
Negative 12 and square root of 10 and positive 12.
Okay, so we can do this. What does that become?
Cancel now.
0,
That becomes 0. Okay, what about the others?
5 for square root of 5.
16 times 5.
Oh, sorry.
That's 80. Okay.
And then minus BB.
No, this is,
The 4, we can break it down.
Yeah, so it'd be
Two.
negative 9
Times
times
two.
2, so that's negative 8.
it'll be negative 18 minus 80.
So it's 80 plus 0 minus 18. What's 80 plus 0?
80,
So now we need just what is 80, excuse me, minus 18?
72,
Not 72.
62.
62. Now, here's what I want you to notice here, is that this is something very special. It's very special, and here's what I want you to notice about it, is that what happened to the outer and inner terms when we foiled these? They canceled. That is not a coincidence that happened. When we've got two things that are exactly the same like that, and one of them has a plus and one of them has a minus, here's what's going to end up happening. When you foil, your O and your I are going to be exact opposites and cancel each other out. So really, you only need to do first times first and last times last. Just to verify that, what is the first term times the first term? Look, we canceled these out right here. That's the outer and inner, right? Here was the first term times the first term, and here's the last term times the last term. So just remember that pattern, because I'm going to show you how that pattern is going to make our life so much easier when things get ugly here. So things are going to get ugly, and we're going to fix it using that pattern there. One was positive, the other was negative. All right. Let's do this one. We've got 3 square root of 2 plus the square root of 5 times what?
3 square root of 0 plus square root of 5.
Beautiful. Riley, keep going.
Okay, so the first term, so it's 9 square root of 4. And then 3 square root of 10 plus 3 square root of 10.
That's our outer terms.
And then the inner would be 3 square root of 10 plus. And then the last would just be 25. Square root of 25.
Okay.
Square root of 25 would just be 5. 3 square root of 10 plus 3 square root of 10. What do you do there?
This is like yesterday. So what did we do yesterday?
So you add
Okay, so what do we get?
the 6 square root of 20.
Let's go back to that x squared plus x squared.
Just 10.
Yep, just 10.
Okay. And then 9 square root of 4. Or you could break down the 4.
And then what does it become?
2. And then 18. Plus 6. Can you break down the 10?
Well, if we broke it down, it's a good question to ask yourself. If you're not sure, you should check it. 2, it breaks down into 2 and 5. I don't know the square root of 2. I don't know where the square root of 5, and neither one of those break down further. So that is a great question, but it's not going to help me on this one.
And then 18 plus 5.
Which is?
21, 20, and 23. Square root of 6.
So not too terrible, right? These are all things that we've done before. It's just a matter of like, I see that a lot of people are still getting used to the feeling of like, what do I do when I add two things that have radicals, and what do I do when I multiply two things with radicals? Now, here's where we get to the interesting part. I'm going to take us through what I call the nerd speak first, and then I'm going to translate it into English. We're about to deal with something called conjugates. And sometimes we are going to have things that are the exact same two things with a plus and the exact same two things with a minus. Remember, we just said we saw that situation a minute ago, right? And when we foil them, it ended up that it was just the first times the first and the last times the last. Because what happened to the O and the I in this situation? They cancel out. So really all that the answer ends up being, notice here, if I took the first times the first, I would get A squared. I'm just going to just show you that real quick. A square root of B times, let me just use parentheses, A square root of B. Well, the A times the A becomes A squared, right? And the B times the B becomes the square root of B squared, but a B can come out of there, right? Because there's two B's underneath there. So it becomes a squared b. This is the nerd definition here. I will give you the simple definition in a minute. And then we do the same thing for the last term. But the inner and outer terms, when they are opposites like this, conjugates, we don't care about the outer and inner terms. They're just going to cancel each other out every single time. Now, why do we care about this? Because sometimes our denominators are going to get real ugly in a way that we've never dealt with, and conjugates are going to be the ways that we solve them. So I'm going to go and show you another here. Now notice, what do I hate about this fraction right here? What is the part that I hate the most? The radical on the bottom. Now you might think that's super easy. I can just multiply by the square root of 5, but you would be wrong, because what would happen is if you multiplied by the square root of 5 down here, it would fix this, but it would break this. Like, we'd still end up with a radical in the denominator. So this, because there are two things in the denominator, become very difficult to deal with. So understand, for those of you who are in other things right now, you're about to miss probably one of the easiest things to do if you know how to do it, and one of the hardest things to do if you're not paying attention. So to get rid of these two things in the denominator, because I don't want that radical there, I am going to multiply by that thing's conjugate. Okay, so think about what I said a conjugate was, and tell me what the conjugate would be. Remember, they were two things that looked exactly the same, but they had different signs. So what am I going to write in that parentheses? Sorry, only this needs to be changed. 3 plus the square root of 5. But whatever you do to the bottom, you also have to do to the top. So just know that. We're just doing the same thing that we normally do, except for we're multiplying both the top and bottom by what we call the conjugate. Notice it's not the exact same thing you multiply by now. It's the exact same thing, but instead of being negative, it's positive. If that had been positive down there, I would write negative. Now watch what happens. I am about to FOIL two things that have opposite signs, right? And we did this a minute ago. The O's and the I's are going to cancel out. So what are the only two things that I need to multiply out here? Okay, what is first times first in the scenario on the bottom? 9. 3 times 3 is 9. In the denominator, what is last times last? Negative square root of 5 times the negative square root of 5 times a positive square root of 5 is negative square root of 25. But talk to me about that square root of 25. It becomes 9 minus 5, and 9 minus 5 is? 4. That is how we fix two things in the denominator. When we have two things in there, now we had to deal with something called the conjugate. So notice that the bottom is now fixed. Now we just need to deal with the top. Are the tops conjugates? No, so they're not going to cancel each other out. We cannot ignore the O and the I like we did before. We can only ignore the O and the I when they're conjugates, and these are not conjugates. So on top, let's do first times first. Okay, 3 times 3 is 9. Let's do outer times outer. 3 radical 5. And let's do inner times inner.
3 radical 5.
And then let's do last times last.
Radical 25.
Radical 25. Let's just see what this... I'm doing this here because I didn't have enough room to do it on the top of my fraction. I knew what this was going to look like. So let's add that up. 9 plus 6 square root of 5 plus 5. And then? 9 plus 5 is?
14.
Okay, so we get 14 plus 6 square root of 5 all over 4. But I wish I could say that we were done, but there's still one more problem. One more problem with this, and we're going to fix that here in just a second. There's only one more thing to do. I'm going to clean this up a little bit. Yeah, so talk to me about how you knew there was still something we could do. Okay, so notice that, here's what I'm going to do. I'm going to show you this as two separate fractions for a moment, so those of you who can't see it yet will be able to see it very easily. These two things are exactly the same. Okay, what I just wrote there is exactly the same as what's above it. It's just, it hasn't been combined into one fraction yet. So why did I separate it out? What's easier to see when it's separated out like this?
Each individual, like each.
Right, 14 divided by 4 is going to give me what? 7 halves. And then what does the other one become? 3 square root of 5 over 2. Now let me just put that right back together again. What does that become?
7 plus 3 plus 3 square root of 5.
7 plus 3 square root of 5 over 2. Now we didn't have to break it up like that. We just had to understand that these two were going to cancel together and these two were going to cancel together as well. That 4 goes with each of those things. It's not like you could just cancel the 14 and the 4. You can't say that 2 goes into 4 and 2 goes into 14 and be done with it. Each of those things has a 4 in the denominator. That's why separating it out like that helps me see it right away. Yes, sir?
Now, do you do this like operation when there's like division? Like where you...
Which operation? This first step?
Yes.
So notice that we're going to run in this what we're doing now, the next 3 examples are all going to be the exact same. So let me show you when I see it. Notice I see the denominator. I see a radical in the denominator again. However, there are 2 things in the denominator, and that stinks for me because I can't just multiply the top and bottom by the square root of 3. If there was only a square root of 3 in the bottom, I would be fine multiplying the top and bottom by the square root of 3, but that's not the case. So when we have a binomial, 2 terms like that, and one of them has a radical or both of them have a radical, then all we need to do is multiply by the conjugate on top and bottom. But what is the conjugate?
2 minus square root of 3.
And I do the same thing on top, 2 minus the square root of 3. Now, what's great is look at the top. Look how easy the top is. What does the top end up being? 2 minus the square root of 3. Because if I take 1 times 2 minus the square root of 3, it ends up as 2 minus the square root of 3. But now we need to work the conjugate on the bottom. Yes, ma'am?
How do you know?
What's that?
How do you know that it's a conjugate?
How do I know that that's the conjugate or that we needed to use the conjugate?
Negative. Like I thought it was negative, then you would put it as
I'm sorry, I don't understand the question. Are you asking, there's 2 questions that you might be asking, and I'm not sure which one you're asking. Are you asking, how did I know to use the conjugate, or how did I know that this number here was the conjugate?
How did you know how to use it?
So I knew to use it because I saw that there were 2 things in the denominator, not just 1, and I needed to get rid of that radical. Before, we've only dealt with 1 radical in the denominator, and so we just multiplied by whatever that was, and it got rid of it. Now we've got 2 things, and if you multiplied both of them by that, it wouldn't get rid of the radical. So this is what gets rid of the radical in the denominator. Right. Now remember, in the denominator, we have a conjugate, which means when we FOIL this, the outer and the inner are going to be thrown away. They're going to cancel each other out. So all I care about is the first times the first and the last times the last. What's the first times the first in the denominator? 4. And then what's the last times the last? Negative. Radical 9. And the square root of 9 is? So we get 4 minus 3. And on top, we have 2 minus the square root of 3. Well, what is 4 minus 3? 1. So we get 2 minus the square root of 3. What's a better way to write this since it's got a 1 in the bottom?
2 over...
When you have a 1 in the bottom, you don't need it. It's just, like, the number 4 is the exact same thing as 4 over 1. We don't usually write 4 over 1 when we're going to say 4, unless we're doing math that needs it there to help us see something. So in this case, we're just going to say that this right here is the exact same thing as this. So this is really my answer right there. I was just trying to show you how I got to it. So don't worry, we have 2 more examples of conjugates. Hopefully, if it hasn't caught on yet, if you're not taking notes, best of luck to you. This is going to be the worst test that you've ever had. I'm telling you right now, there's just too much going on here for you to not try it. So let's go to C. Notice on C, there are 2 things in the denominator, and one of them is a radical. So what am I going to multiply by? Like, what is the name of the thing I'm going to multiply by? No, what is that vocabulary word? The conjugate. Again, I'm not going to give you a vocabulary test, but I want you to just be able to use the word. So what is the conjugate of x plus the square root of y? X minus the square root of y. And then what goes on top? Same exact thing. X minus the square root of y. Well, what is 1 times on top? What is 1 times x minus the square root of y? Now let's talk about the bottom. We have conjugates, which means that when we FOIL, that O and the I are going to cancel each other out, so we can kind of disregard them. So talk to me about first and last.
X squared, X squared.
Okay? And what about last?
The square root, radical of y. Negative.
Negative. X squared of y squared.
Of y squared. Now notice I still have a radical in the denominator. However,
Well, I mean, it goes into it, so it's
squared
just
minus
y.
right, if you think about this right here, let's talk about this square root of y squared. That's y times y, right? How many y's do I need to be able to pull out a y? 2, and I have one. So this is going to end up, my top stays exactly the same, and the bottom becomes x squared minus y. Because the square root of y squared is just y.
Wait, then how did you get x squared?
Because it was first times first. If you look over here, first times first.
Oh, but it's not in a radical, so it's not.
Correct. There was never a radical there. Now, I'm looking at it. The denominator is okay because there are no radicals there. It doesn't look like anything can be combined, so this is going to be my final answer there. I'm just going to get rid of some of those circles for a minute.
Wait, why can't you, like, cancel the x's?
Well, because remember, these are two separate things.
Oh,
So, like, I would have to cancel it by all of this. If this were exactly the same as the top, I could cancel it, but it's not exactly the same. All right. Here's my final answer on this one. And in just a second, we'll do D. And then we're almost done for the day.
wait, can you zoom in? Oh, yeah.
Zoom in, zoom out, zoom in. I'm just giving you a hard time. All right, we only have about 8 minutes, so we kind of need to move quickly here. Notice, two things in the denominator. They are both radicals. What am I going to multiply by? The conjugate, yep, what is the conjugate? Square root of 5 plus the square root of 2. And the same thing on top. Well, the top is nice and easy, right? Because that just ends up as the square root of 5 plus the square root of 2. If you want, you can keep that in parentheses if that helps you. What does the bottom become? First times first, last times last.
The square root of 25
Square root of 25 minus
four.
the square root of 4. And let's just work that out there. Let's go.
So 25 goes to 5 minus 2.
Sorry, I'm just catching up. So square root of 25 is 5 minus the square root of 4, which is 2, which ultimately becomes.
3.
So we get the square root of 5 plus the square root of 2 over 3. What if I took the top and I turned that into the square root of 7? Is that good?
No,
Why not?
because they're not the same.
You can't add those together. They don't have the same radicals. You can't add them together.
So you really don't touch the top of it.
You might in some cases, but in all the cases we've had, no, you've never touched them.
So they have to be the same?
Like, if I want to add two radicals together, they have to be the same. Like, I can add the square root of 9 plus the square root of 9. It does not become the square root of 18. What does it become? That is not the square root of 18. What does it become? 2 square root of 9. I have 1 square root of 9 plus another square root of 9. I have 2 square root of 9 now.
We haven't done that though, right?
We did that yesterday. To add two things or subtract two things, they have to have the same radical. Again, this was not for this problem. This was just me making this up. Yes, ma'am?
Why is it negative and where is radical 25 radical 4?
Because if you go back to what we were multiplying, the last times the last, a last thing times a last thing, a negative times a positive would be a negative. Okay, we have two more we've got to get through, and we've got to get through them pretty quickly. So stick with me. It says if f of x is equal to x plus 1 over x, then they want you to find f of 3, square root of 3 plus 2. What this means, and you're going to want to make this note, or you're never going to get this right. What this means when they do this is replace x with this. Every time you see an x, I want you to pull it out, and instead of using an x, I want you to put that in. That's what this means. So they want us to figure out what this is going to equal if every time I see an x, I swap that x out with this. So if f of x is x plus 1 over x, I'm going to do this. We write it like this. F of the square root of 3 plus 2. Notice that instead of writing f of x, now I'm replacing that f of x with a square root of 3 plus 2. So the first thing was an x, so I'm going to replace it with a square root of 3 plus 2. But they added 1 to whatever that x was, so I'm going to add 1 to that. Notice I pulled out the x and I replaced it with that. Let me just show you what's being replaced. This x became this. This 1 was still that 1. What am I going to write in the denominator? What's in the denominator? Right, there's an x there. So I'm going to replace that x with a square root of 3 plus 2.
So the x is, so square root of 3 plus 2 is replacing x.
Right, they're telling me to replace all the x's with the square root of 3 plus 2. Now, we're not done yet, but we're pretty close. Look at the top. There's still something that can be done on top. And it's probably what you think it is. So if you're like, I don't want to say it, you're probably right. What? Add 1 to what? To the 2. And so we get the square root of 3 plus 3 over the square root of 3 plus 2.
Wait, so you can't just like cross those off?
Remember, this is one thing and this is one thing there.
But like from the top.
Up here?
Yeah. You can't.
These two things are being added. That's a good thought. They're being added together and not being multiplied. So you have to watch out for that because they are being multiplied together. So we get the square root of 3 plus 2 is in the denominator, which is not okay. Why is that not okay?
Because you can't have a radical.
So how are we going to fix it?
The square root of 3 minus 2.
Good, the conjugate. We have to multiply both the top and bottom by the square root of 3 minus 2. Now there's going to be some work here. This is going to be the last one we're going to do for today. There's only one more problem, so it's not a big deal. On the bottom, what am I going to have when I do that? Remember, it's only going to be first and last because those are conjugates.
So square root of 9
Square root of 9 and
minus 4.
negative 4. What is the square root of 9?
3.
Okay, so that ends up being 3 minus 4. And what is 3 minus 4?
1.
Negative 1. Let's do the top. Are the tops conjugates?
No.
No, because they're not the same thing. They're very close, but they're not the same thing. So we have to do first, outer, inner, and last. So I'm going to do that. Let's do first, outer, inner, last on these two right here. Those two binomials. First times first.
Square root of 9
Square root of 9. Outer times outer.
minus 6.
Here's outer times outer right here. What does that become?
Because they're not conjugates.
Negative 2 square root of 3. What about inner times inner?
Square root of 9.
3 square root of 3. And last times last?
Negative 6.
Okay, we got to simplify real quick. We have about a minute. What is the square root of 9? What does this become?
1.
Just the square root of 3. 1 square root of 3. Minus 6. What is 3 minus 6? That becomes negative 3 square plus the square root of 3. So we get negative 3 plus the square root of 3. This ends up over here, negative 3 plus the square root of 3. We'll finish that one up tomorrow, but
We do FOIL because it wasn't a conjugate.
because it wasn't a conjugate, right.